All right. Okay, so thank you for joining us today for our Lunch and Learn, where we will discuss an overview of spray transfer efficiency, why it's important, and free training opportunities that PPRC has been delivering for years and years for spray coating professionals. And we will also touch on waterborne paints and the ease of transitioning and the benefits of transitioning. And then we'll have time for Q&A at the end. So I'm Brittany Wendell. I manage and coordinate the Oregon EcoBiz certification program. And I'm joined by my colleagues, Ken Grimm and Mikey Strawhall, who deliver the spray efficiency trainings through PPRC and will be taking over in just a moment. We're also grateful to have Paul Ireland here joining us today. Paul is with NCS, which is a coating and paint distributor. So just a small bit of background. This event is hosted by EcoBiz and PPRC. The PPRC, or Pollution Prevention Resource Center, serves as third-party providers who implement the EcoBiz certification program. And we receive funding from local jurisdictions, from the state of Oregon, and EPA grants to administer EcoBiz and provide non-regulatory third-party technical assistance. And we've been doing this for about the last 14 years or so. EcoBiz is a free and voluntary certification for businesses that meet high standards to protect the environment and prevent pollution. And the program requires that all businesses prevent pollution across air, water, and land. The certification is also currently only available in Oregon to Oregon businesses with a focus on the automotive sector, including auto repair, body shops, dealerships, car washes, and public agency fleets. Each certified location is verified and supported by our state agency, by Oregon DEQ, as well as the local water authority where the business is located. So both parties need to verify certification. And EcoBiz is the only green business certification in Oregon that was developed in part and backed directly by the state. So these are all the groups and agencies that have put time and effort into developing and funding the program over the decades. So you can see Oregon DEQ, a lot of our local water jurisdictions and cities. It's a great group of partners. And EcoBiz works with many auto body shops in Oregon, providing free technical assistance and resources and helping businesses work towards certification. So if anyone has any questions about the program, please review our website. It's just ecobiz.org. And feel free to reach out to me as well. My contact info is here on the screen. So I will pass it off to Ken Grimm, who will share about our free training resources and information about spray efficiency.
So hello, everyone. Thanks for joining us. As Brittany mentioned, I'm Ken Grimm. I am the Industry Outreach Manager for PPRC. And just a little bit about me. I have about year and a half of auto body experience right out of high school, and almost 18 years of industrial experience before I came to PPRC to do a variety of things, but and in particular to start the spray efficiency program. So what really got this thing going was the 6H NESHAP, and it still is one of the drivers for getting the training. Although it's kind of interesting, it went from cost savings to meeting regulation, and now the driver seems to be back to either a cost savings or somewhere between the two. And the 6H covers paint stripping operations that use methylene chloride, and they're getting fewer and farther between, but there still are some out there. And mobile vehicle and motor vehicle spray applied surface coating operations, and in particular any coating that contains one of the 5 target metals that they're looking to eliminate if possible. So part of what that standard requires, you can see, a number of the things here, like spray gun cleaning requirements and filter maintenance requirements and particular guns, etc. But it also requires that the painters complete training techniques to minimize paint overspray. And that's one of the things we've been doing for quite some time. And I don't have photos of it up in this presentation because I didn't want to drag it out too terribly long, but we've gone from basic training to a training with a 2D virtual reality system to now we have a 3D VR system that it looks like you're actually placed inside a booth with a variety of different parts that you can practice the spray efficiency techniques on, so that you can excuse me, you can demonstrate the hands-on requirements without ever having to don PPE and get in a booth and spray something. So real quick about guns. It lists electrostatic, airless, HVOP, and air-assisted airless as the acceptable guns. And there's also a line in the regulation that says or equivalent. And the EPA has certified these 6 guns as meeting that same equivalency, so that essentially what they want to do is get rid of all of the old guns that were, in and of themselves, that were about 30% efficient, transfer efficient, and move people onto guns that are, theoretical transfer efficiency of 60-65% or more. So, one of the things that we talk about is, in the training is why are they addressing surface coating? And one of the little items I found was a quiz that says, ask what percentage of US manufactured items are fully or partially painted. And I kind of get questions all over the board. Some people tend to go automatically for the top. And so I actually didn't put the correct answer in here. The correct answer in here is 70%. About 70% of the items manufactured in the US are fully or in some part painted or coated. And so there's a tremendous amount of this going on, and that's why surface coating is being addressed as much as it is. So, when we work with painters, we particularly work with controllable variables. There are some things that a painter can't do anything about, like booth size and, the air makeup unit and, that sort of thing. But they can control the mixture content, the temperature they operate the booths at frequently, the type of spray equipment they're using, and then gun setup practices and equipment maintenance practices can also have a big effect on both the efficiency of your spray and the quality of your finish, depending on how well you're performing both of those functions. So the other thing that we talk a lot about, and this is what the 3D VR system is good for when we do the hands-on training, is consistent proper distance, the consistent proper angles, other techniques that add to efficiency, and if you're doing a job shop and you have different things, kind of developing a plan of attack before you even pull the trigger on the gun. And these sorts of things are in here because through a really exhaustive study, actually, one of the things that's come out of that is that no matter how transfer efficient the gun is, painter technique has the biggest effect on transfer efficiency. And also most painters, there's not a lot of formal paint training out there, so most painters learn to paint from somebody that learn to paint from somebody that learn to paint from somebody. And they're good at doing the two things their boss wants: do it fast and do it right, but their techniques are all over the board. And so what we talk to the painters about is we're not teaching you to paint, we're providing you some technique refinements that you can use to help improve your transfer efficiency, help improve your consistency, which generally means help improve your quality. So transfer efficiency, I've been talking about that a lot. What does that mean? Well, our working definition is it's the measure of how much paint you sprayed actually ends up on the part you're trying to paint. So that's measured by either mass of solids deposited over that sprayed or volume. Either one of them works to give you a good transfer efficiency figure. And this is important because, you know, with the old conventional guns, there were painters that had transfer efficiency in the teens, and you could walk into a shop and look in the booth, or sometimes into the shop because they didn't even have a booth, and the whole thing would be just this fog of paint overspray. And I still see that on occasion, even with HVLPs. So why is that important? Well, you know, other than, you know, material savings, because it's, you know, if you're using less paint, you're spending less money, you're creating less waste, you're creating less hazardous waste, which also means you're spending less money. And so it can have a surprising amount of savings in the long run. And there are also some significant health impacts to think about, not only for, you know, the surrounding community, but for the painters and the employees in the shop themselves. There can be some pretty significant health impacts. This is kind of a look at the ways that paint spray can affect the human body, both acute and chronic overexposure. And of course, acute overexposure is a single incident, and chronic is repeated. And I think those of us in the paint industry all know guys that have the shakes, you know, their hand shakes like almost like Parkinson's, and it's basically due to central nervous system damage from overexposure to solvents over a long period of time. And I myself wouldn't go back and work in a booth. I sometimes step in and work with painters, but I don't do that much because I've got industrial asthma or occupational asthma from my time as a painter. So there are a lot of ways that this affects painters. And in fact, what painters don't realize is that a lot of times they're bringing this stuff home to share with their families. So also, why is it important? Well, we have done some measuring of painters, actually a quantifiable measure of transfer efficiency. And what we found is that, you know, even good experienced painters can have a transfer efficiency of 50% or less. And in fact, most of them do. What I found is that, excuse me, there are some in the high 30s. Most of them are in the low 40s. And after training, we've gotten them up into the 50% area, but very few of them start that way. And, you know, just a 10% improvement can have a significant impact on both emissions, waste, and cost. So as a visual guy, I kind of created this slide because it helps me picture it better. So if this pie is the paint you've purchased to use, and you're at 40% transfer efficiency, the orange part of that is the paint you've purchased to put on your product, and the green part of that is the paint you've purchased to waste, whether it be into the air, into the filters, on the floor, you know, whatever. And even worse than that, in a lot of instances, that green piece of pie is the paint you've purchased and spent money on, so that you can later spend money paying somebody to take it away if it is in fact hazardous waste, or for some other reason can't be disposed of in the solid waste disposal. So again, money, these figures are pretty dated. But you can see that, you know, if you're shooting at 40 and we can get you up to 50 in transfer efficiency, you're looking at probably about, in just that instance, about $6,000 per painter. And these are like 1996 or 97 paint prices. So a bit of an increase in petroleum products since then. Oops. We also, when we're working with painters, we also talk about build efficiency. Transfer efficiency is important, but it's not the only thing we want to work with painters on, because you can have 100% transfer efficiency and say you shot you put 6 mils of paint on a product, but you only needed 3 mils, well, you've wasted 50% of the paint in that instance as well. And all painters put more paint on than is necessary because they're all going to make sure that if there's if there's an error, it's going to be because the coating was too thick and not because it was too thin. I've never met a painter that wouldn't pick too thick. And so we look at build efficiency as well to see where there are other areas that that could be improved along with transfer efficiency and just get that much more out of the savings and out of the technique changes and things like that in your system. And I regularly went out and took mill readings of the product when I was working when I was running the paint shop. And most of the painters, it was surprising, most of the painters, and you'll see it later, use different amounts of paint, but they all had about the same millage on the parts. So the techniques we particularly work with painters are the consistent proper distance, keeping the gun perpendicular to the surface, avoiding some of the oddball spray angles, keeping a consistent 50% overlap. There are some coatings now, particularly some of the metallics, that want a 75% overlap, but the general rule of thumb is to get a nice 50% overlap as you're painting, and then using banding and edging techniques and reducing your lead and lag. So we also look at equipment and getting equipment set up, the air pressure settings. We do a lot with air-assisted airless, electrostatic, and airless as well with fluid pressure. Well, airless is just fluid pressure. The other two are both fluid and air pressure. And then HVLP, a gravity-fed HVLP is air pressure. And it should be about 29 PSI or so at the gun and about 10 PSI at the tip. If you start getting up to 11 or 12 PSI at the tip, technically it's not an HVLP anymore. So setting the air pressure at the lowest that allows a good atomization and good coverage is one of the keys. And among other best practices we work with are using the correct nozzle or tip as per the manufacturer's recommendation for the coating they're spraying, setting the incoming air at the maximum and making adjustments at the gun, mixing the product to the recommended viscosity, and of course a lot of the collision repair coatings, that's not really the issue that used to be when you would just take the lacquer and thin it where you liked it and go spray, because most of them are plural component and you mix it 4-2 or 4-3-1, whatever the coating is, and so they really don't thin it. There are places where some of the guys do that sometimes, but for the most part you mix it to the recommended viscosity and go, and it should be good. And then spraying a test pattern to make sure that the gun is the settings are right and the gun is right. So you can, I just set up a piece of cardboard or a piece of paper on the wall, something like that, give it a quick shot, and it gives you a good idea of whether you've got the spray pattern you want, which looks like something here in the center. On the left, I would guess that's either the fluid pressure is too high or the air pressure is too low. And on the right, you've got the reverse. You've probably got too low a fluid pressure or too high an air pressure. And in either case, when you look at those things and you start thinking about a 50% overlap, you can see that there's going to be some problems in the coating. And in fact, one of these can be one of the causes of tiger striping. So gun distance, we work with painters to make the gun to keep the gun at the proper distance from the part. This is a manufacturer's chart, and these are average distances. So generally you see a range for HVLP. You'll see 6 inches is like the recommended average, but you'll see it ranges from 5 to 8, sometimes even 9. I've heard people say 10, but I personally think you start getting out to 10 inches with solvent-borne anyway, and you're going to have some problems. There's a certain amount of atomization that happens between the gun tip and the substrate. And, there are various solvents in there, high flash, low flash, that are all designed for a specific job. And you start changing the difference, you start changing that. So, air-assisted airless, 8 to 12 inches, electrostatic, about the same, airless, 12 to 18 inches, maybe 24. I mean, you can crank them way up and stand back, but again, you're not applying the coating per manufacturer's application instructions. And so if there's any sort of failure, that may be that'll come back to the company and not to the manufacturer of the paint. It's another descriptive graphic from this one's from SATA, and too far away and you're getting too much flash and it isn't really as smooth a layout as you would like. Too close and you may be getting some center blowout, and that may fill in a little bit as the paint settles, but it again is going to create some problems down the road. So keeping the distance consistent is one of the key things that we work with, and you'll see that here. You can see that red dot on the hood. That's from a laser that was developed as a training aid. And if you get too close or too far away, or you start getting the gun angle too far left or too right, that breaks into 2 dots. But you can see here, he keeps that at one consistent dot until the gun comes off the hood. You just saw it break into 2 there, and you'll see it again when he comes back off of here. It's 1 dot all the way across. Then it breaks into 2 as he comes off because the distance has changed. So that's a useful tool, and it's a way for painters to get used to what consistent distance looks like. But I've seen painters that have used that, and it really doesn't take them very long before they make that adjustment in their muscle memory, and it becomes part of what they do. So there are a variety of different things in terms of angles that we try to get painters not to do. One of them is yaw, which is moving the wrist left or right, and you'll see an example of that here. And he's sort of exaggerating that a little bit because he's demoing it, but one of the consistent things, the most consistent thing I see going into shops is this little wrist flick coming off the edge of the part. And I think it's one of those things that, painters have done for so long that painter trainees think, oh, when I can do that, then I are a real painter. And that really there's no value to that, because in fact, what you're doing is losing your distance and your angle and your technique, and then getting it back every time you come off the part. So, we try to discourage that. And the other thing that goes along with that is frequently people will, and it's just as often as that wrist flick, we'll see people that don't trigger the gun. And so they come off with that wrist flick and come back. So the whole time that they're moving that gun from start to the time that hood is painted or the part is painted, whatever, they've got that trigger down and they're spraying paint. So here's a look at how that kind of changes the angle of the spray pattern. And again, when you're talking about good consistency and good overlap, you're gonna work against yourself when you're doing that little wrist flick thing if you're still on the part. The only time that's particularly necessary or called for is when you're blending, when you're shooting a part of a panel and you're blending it in. So lead and lag was one of the things that really helped save paint. And so for definitive purposes, lead is, the distance between where the gun's triggered and where the gun hits the part. So and lag is the distance between where the gun and the pattern leave the part and you let go, you untrigger the gun. And so keeping both of those to a minimum can have a significant effect. For conventional lead and lag, there's kind of a diagram here, but this is a video, and it's very visible here because we've laid out paper, And so it captures the overspray. And in a shop, this would probably be sitting on a stand, or would be on the vehicle with paper covering the rest of the vehicle. And so you wouldn't necessarily pay attention to it. But what I see him do here, I would say wouldn't be uncommon in any shop that I've been in. So working with that, what we try and do is kind of tighten up that lead and lag, and you'll see a really good example of that here. So if you look at that little bit of overspray here and think back to that last slide of what was there, and you calculate that surface area out around that hood, that might be 10% of your coating right there, just in the improving the lead and lag. And it's a little uncomfortable trying to tighten it up like that at first, because no painter wants to start too late or let go too soon. But again, it's one of those things that, when I worked at it, it was very uncomfortable for me, but it didn't take very long before, there wasn't a conscious thing I was doing anymore. It just became part of the way I painted. And, the painters that I had, these guys were all there a long time. One of them, or two of them, had significantly improved their lead and lag, and they were better at triggering the gun than the other two. And of course, that's the two guys at the bottom. They were using 5 gallons of primer each, compared to 5.5 and 5 3/4 for the other two, and they were using between 3/4 and a gallon less of paint. And when you see that orange box at the bottom, we would shoot like 4 of those each booth, two per shift, times 2 booths, times 2 shifts. So we were getting 8 of those out a day. And if you're saving 8 gallons of paint a day, that is a pretty sizable material savings, just in improving your lead and lag and in triggering the gun. And this is at Teledyne Energy Systems in Hunt Valley, Maryland. They paint these screens, and they go into machines that crack water and crack hydrogen from water for energy purposes. And so what they do is they have to have a certain level of resistivity in the screen, and so they paint this heavy nickel coating, which is what got them into 6H. And they mix up 90 cc's and they go down. And what they would do is they would go down these 5 screens, and then they would come back 1 or 2 before they started running out of paint. And when we went through and I video the painters before we did the training, and so we run through the training and then we look at the videos, and they can all see themselves what they were doing that they might be able to change. And we decided that we would just go back and work at improving the lead and lag and triggering the gun. And so from 1 pass plus, this was the result, coming back and trying it and with the improved lead and lag and triggering the gun. So he's already gone way past what he had done initially. So these panels now have fully 2 coats of paint on them. Now you can see he's starting to run out of material. So they went from basically a single pass to getting more than 2 passes on these parts. And they have to go through this process then they go through a dry off oven, then they go through a bake off oven for 30 minutes at 400 degrees. And each screen goes through that process 7 times. And just by tightening the lead and lag and triggering the gun, they were able to cut that down to 5. And I have not talked to them. The guy that used to work there, that was my contact, is retired. But the last I talked to him, he said they were gonna run some tests on doing it, making 4 passes with it, which would mean that if that was successful, then they would cut out 40% of their paint use, 40% of their labor, 40% of their energy costs for drying and baking this stuff, 40% of the damage from handling it over and over again, et cetera, just from improving the lead and lag and triggering the gun. And so I don't know what the time is. Yeah, I'm running long. So quickly, if you're at 50% transfer efficiency, shooting about 170 gallons at the example we have here, if we can get you to at 40 rather, if we can get you to 50, you'll go from 212 to 170 gallons of paint. That's 42 gallons a year of paint that you're going to save. And again, if you're at, say you're at 4 or 5 on your mill build and the mill target is 3, I would work with you to try to get down to 3.9. I'd love to get you down into the 3.6 neighborhood. I don't know about 3.3, and I wouldn't even worry about trying to reach 3 mills. I've checked cars on lots that have come out of the factory that are painted by robots, and they're not consistent. And so, in fact, there's usually a variant of about 0.5 mil among those. So I wouldn't ask any human being to do what a robot can't do. But if we can get you from 4.5 or 4.2 to 3.9 to 3.6, that's another 10 or 20 gallons of material you're saving as well. So at Woodfold Manufacturing in Forest Grove, I worked with them, and the first year after the training, they did a case study, and they saved $3,000 in labor and material savings for filter changes they weren't making, largely but not entirely because of the reduction in overspray that they had. And they saved $34,000 in paint costs. They purchased $34,000 less paint, and their production factor went up by a factor of 10%. So they shot more parts with $34,000 less paint. So I'm going to leave you with this before I hand this to Paul. This table looks at the toxic weighted emissions of some of the sectors. These are cancer-causing chemicals that are put out in the air every year. This is the manufacture of agricultural chemical and pesticides, 312 tons of cancer-causing chemicals into the air every year. Pharmaceutical production, 523. Paint and allied products, this is your PPG, your Sikkens, your Rada, your Sherwin-Williams, your folks like that. Almost 2,400. Industrial boilers, flexible polyurethane foam operations, and this is collision repair. And this figure has gone down some since these were first collected. But the other thing to keep in mind is that this is just collision repair. This doesn't count all of the aerospace paint, and aerospace all uses chromium primers, and it doesn't count industrial paints. So there's a significant amount of toxics being used in paint out there, and that's one of the reasons. This is my contact information. Feel free to email me or call if you have questions or comments or anything. I'm always happy to talk with you. And this is one of the things that we can do to help this is move on to waterborne, which is what Paul is here to talk to us about. So I am going to hand this over to him because he's got a lot of great things for you. And Paul, I'm
all right.
Back to Brittany. I don't know if you want to take the screen, but it's all yours.
All right, thanks. Yeah, I don't have a screen. So Brittany, you can go ahead and throw something up if you'd like. My name is Paul Ireland. I'm with National Coatings and Supplies. I've been in the industry for probably 30-ish years, working in shops in pretty much every role in shops, and then in 2005, moved over to the supply side, and I've been a technical consultant, which just kind of means glorified painter. I'm doing a lot of instruction and problem solving. And this topic is something that's important to me. I have 4 children, and I'm trying to leave our planet a little better than well, as good as I can, I guess. I can't say better than a generation before, but as good as we can. Traditionally in the collision industry, we were using exclusively solvent-borne paints. I won't go into a whole history of paint through lacquers and enamels and alkyds, but up until probably 10 years ago, I would say all of our customers were, for the most part, were using solvent-borne paints. As the 3 DARE districts in California put a 3.5 VOC mandatory output on those districts, and then there was 13 districts, the OTC districts from Maine down through the East Coast implemented it, the same 3.5 regulation, as well as around Salt Lake City, Utah. Every paint manufacturer started to scramble on, we need to get our waterborne paint up and running. The US was a little behind. Europe, I think in 2006, if I'm not mistaken, went all 3.5, and the quickest way to get there was with waterborne. I think about 2009, Canada did as well. So that's every auto manufacturer is using a waterborne product at that point to get that VOC down. As far as the undercoats and overcoats, so your primers and sealers underneath are still solvent. Your clear coat going on top is still solvent. But the VOC of those products has dropped dramatically. And what we've seen in the industry is, as soon as we start getting products around in 3.5 VOC and lower, we're getting better products. We're getting coatings that are easier to spray, that are better, that look better. The depth of image is better. And now with over 70% of cars being manufactured on Earth, it's easier to match the colors using a like and kind product. So if you are in a shop and you get a brand new car, it is so much easier to match it with water. And I have multiple situations where I have a solvent customer and I have to go mix up waterborne for them so we can match a color, because you just can't, the clarity and the brilliance of the pearls and metallics and the cleanness, the chroma of the color is really hard to achieve with solvent. As it stands right now, I've got less than 4% of my customers are still spraying solvent. And one of the reasons is, although we had a lot of early adopters that just thought, this is coming, we're going to just do it. In the beginning, everyone was really afraid. There was a lot of information saying, well, you're going to need to get a new booth. You're going to have to spend $200,000 on a new booth. You need a bunch of equipment it was just this huge list of things you were going to need. And over time, we started seeing shops that had no bake cycle, limited heat, switching to water and being successful. The other misconception was it's going to be expensive. Waterborne's more expensive. The paint's more expensive. We can't afford to make that investment. What we've seen is it's actually less expensive to be spraying water than it is to spray solvent. And there's several factors that go into that. The first thing is just the amount of product you have on site is less. The containers are usually a half a liter or a pint rather than a full quart. There's very few gallons of toner. So the actual paint on site is usually about 50% less inventory you carry. And part of that is it covers so much faster and so much better. There's less coats. So like what Ken was talking about, we've got multi-shop organizations that are nationwide, that everything they paint goes across the scale, and they're limited to about 2 ounces per panel on a job. Now, some panels will take more, some will take less, and that's about the average. Versus traditionally, if you're doing that with some lines a coat and a half, other lines 2.5 coats. And with solvent, there are several colors, you'd be 4, 5, 6 coats. The other way that waterborne is less expensive is you're using less paint, which means less coats. So excuse me, in a traditional solvent application of base coat, you'd put on a coat, it flashes for 5 minutes. You put on another coat, it flashes for 5 minutes. And let's say it covers well and you put on another coat, and in 3 coats you have achieved hiding and you're ready for clear. Well, now for every coat you have 5 minutes of flash time, so that's 15 minutes. So you start adding this up and it's very time consuming. Most waterborne paints, you're either putting a coat on, blowing it dry in about 15 to 30 seconds and putting another coat on and getting hiding, blowing that dry in about the same amount of time, and you're ready to clear. So most shops are seeing throughput to 1 to 3 more jobs in a day they're able to get through, which just means more money at the back end. So even though a specialty toner may be more expensive, you're using less of it. So that's what we've seen. I have people ask me all the time, if you were going to open a shop tomorrow, what would you put in? And there's no hesitation, it would be waterborne. And I'm trying to speak in generalities. I'm not going to push one brand over another. Each one has their own strengths and weaknesses. It's kind of like trying to have an argument over Toyota versus Honda or Chevy versus Ford and Dodge. It's kind of irrelevant. They all do the job. Otherwise, they wouldn't be in business. One of the main things, the big gains on the waterborne paint is the speed. And I would say right with that is the color match availability. And in the last few years, we've started getting some really, we went from the 2000s that were generally you'd spray 8 silver cars for one of any other color. It was just silver, silver, silver all day long. And in the last 5 years, we've gotten these tri-coat reds and these really complicated, very small metallic, very small grind aluminums that we just can't achieve the depth and the look with solvent. It's very difficult. With water, it's a breeze. So the industry's moved towards waterborne. Most of the color development technology is going towards waterborne. A lot of paint manufacturers are just not putting the same kind of research and development into their solvent that they did, say, 10 years ago. So with the industry moving towards water, that's been the focus. And then also now in the last 5 years, UV cured primer has been becoming the standard, which is a non-isocyanate product. So it's less harmful. You put less of the material on because you lose less during the dry process. And you're able to cure it with a lamp in, depending on the lamp, 10 to 90 seconds versus priming something and then coming back the next day. And then you're able to prep it and prime it. You can receive a job from the body shop, prime it, dry it in under 3 minutes, sand it, prep it, mask it, and put it in the booth. So that's just driving more vehicles, more jobs, and more profit for the shops. I'm yet to see any product that has been restricted not speed up and be a better product. Overall, every regulation that's come down in the last probably 15 to 20 years has done nothing but improve the product, improve the processes. I'm yet to have a water install that the immediate, the first week, the benefits weren't seen. That's all about all I've got. Not sure if anybody else has to jump back in. And if there are any questions, please let me know. I'm here.
And I just like to say that Paul is a glorified painter in the same way that a neurosurgeon is a glorified hospital worker.
Mm-hmm. Well, that's very kind, Ken.
Yeah, Boris.
Hi, thank you. Great presentation. I had a quick question about the waterborne paints. Have you seen a drastic reduction in the HAP use because facilities are, moving towards the waterborne paints?
Absolutely. I'll jump on that one real quick. Absolutely. We do, at the end of each year, we do a VOC report for each one of our shops. We bring up they have to report the gallons of VOC containing paints. And even though it's a process, right? There's an undercoat, there's a base coat, there's a clear coat. Just all of our clear coats going from 5.5 to 6 VOC or VOCs down to 3.5 and less, and then just adding waterborne in, it's cut dramatically. I would say close to 50% over a full-blown all solvent shop, because that base coat you're putting on twice as much, if not more, to achieve hiding, whereas the water's going on, and we're talking some of the water is under 1 VOC, because you still have about 10% solvent in most of the waterborne paints. Mm-hmm. So incredible reduction. We also have eliminated all lead, all chromium. If there's any chromium, it's trace, which is incredible. And then also methylene chloride paint stripper has been removed. I can't speak for any other supplier, but we do not sell any methylene chloride anywhere in the country. We completely dropped it. So all those things combined, and then combined with UV, which is a great product. It goes on, you cure it, you can pour it back in the can. There's no waste. The only waste is maybe cleaning out your gun. Most guys just leave it in their gun because it doesn't go off unless it's exposed to UV light. So you're taking what was, say, 12 to 14 ounces of primer for a job, cutting that to 6 with 0 waste. And with waterborne, you're cleaning the gun with a water cleaner and also acetone, which is an exempt solvent and evaporates almost immediately. And the big 55-gallon waste drums that we had at these shops for years and years and years, most of my shops have a 5-gallon waste for their solvent, and most of them recycle that in basically like a cooker. It cooks it off, cooks down the solids. They recycle the thinner and use it for cleaning. And for our waterborne, it's going into like a floor sweep situation, and then they can dry that, and then it's not hazardous waste. It's dry paint in basically kitty litter. So the amount of waste that's been cut has been phenomenal. I can't even begin to explain how much less waste there is. And then the actual emissions, I would say, are cut up at least probably 40%. That's being conservative. It's really been amazing. It's been an amazing change in the last decade.
Thank you.
Mm-hmm.
Thanks, Paul. Thanks for your question, Boris. Any other questions regarding spray transfer efficiency training or switching to waterborne paints? Well, thank you, everyone. Our contact information is up here. So if you would like to contact Paul with any questions, he has decades of experience and knowledge. If you'd like to contact Ken, his email is right here. Mikey is also a spray efficiency trainer. He's on the call today as well. And then any EcoBiz questions can come to me. So with that, I will conclude this webinar. So thank you so much for being here, and hope you have a wonderful holiday and great rest of your day. Thanks, everyone.
Thank you.
Happy holidays. Thanks for having me.